Alright, so we're on our last video here, and this is actually going to be one of the hardest problems on the test, as far as it's got a lot of work, a lot of algebra. Now, sometimes students can play around with the numbers and figure out what the solution is, or maybe one of the solutions, and I might give you a point or a half point if you get one of the two and there's two. But in order to get full credit, you're going to have to do the algebra, which is quite detailed. There's a lot to it, as you'll see here. I've already worked this one out. So we started here. Actually, let me cover up over this. So we started here, and we learned that with radical equations, if there's two radicals, you want to get them on opposite sides. So that's what I did first. And so now I'm going to square both sides. Now the left side's the easy part. I'm just going to get 4y plus 1. But on the other side, I'm going to need to FOIL that out. And so that's what I did here. And so you end up with 4y plus 1 is equal to 7 plus 6 square root of y minus 2 plus y. So here's where I FOILed that out. Now, once you get to this step, sometimes students get lost, but you got to keep in mind what we're trying to accomplish. We now have just one radical, and so when you have one radical, what you want to do is isolate the radical and then square both sides. So I'm going to subtract 7 and y from both sides. And I will get 3y minus 6 is equal to 6 times the square root of y minus 2. Now at this point, you got to be a little bit strategic. I mean, there's more than one way to do this, but the easiest way is, originally I would want to divide by 6, but that's going to leave me with a fraction here. And then I'm going to be squaring both sides. I'd rather not do that. But notice these are both divisible by 3, so I divided by 3. And so I end up with y minus 2 is equal to 2 times the square root of y minus 2. And so now, even though I didn't get rid of this number here, if I square this, it really isn't that bad. And I'd rather do that than deal with the fractions. I mean, it doesn't matter to me about the fractions, but makes this easier for most students, so that's why I'm doing it this way. So you can see I squared the y minus 2. I'm squaring both sides here. And here is the right side, and here is the left side work. So I like to do that off to the side so I can keep everything nice and clean on the left. So you end up with this quadratic equation. So we're going to want to get 0 on one side. So I subtracted 4y and added 8 to both sides. And this actually factors quite well. It's y minus 2 times y minus 6, which means you get 2 and 6. Now, it's quite frequent that when you get two answers, one of them doesn't work. And by the way, just because one of them's negative or both of them's negative, it doesn't mean that at least one of them, or that both of them won't work. You've got to double check. So I'll just tell you that if you plug in 2 and you plug in 6 in for y, they both work. The main thing you want to watch for is that you don't plug in a number that causes you to take the square root of a negative. Like if I had y equals 1, then I'd have a problem here because 1 minus 2 is negative 1, and I'd be taking the square root of negative 1, and that's not, we can't do that. All right. Let's go ahead and look at the next problem. So this yard or landscaping company has 56 meters of fencing with which to enclose a rectangular garden. The garden is X meters long. Express the garden's area as a function of the length. Well, there's a couple of things going on here that make this easier, but you kind of got to take it step by step. Let me show you how to do it. The first thing you want to do is make a rectangle. Now keep in mind, I didn't know this part to start. They told me that the length is x meters long. Now I have a formula for perimeter. It's 2 times the width, or P equals 2 times the width plus 2 times the length. And so we know the perimeter. Now remember, the fence is just the distance around, so that's perimeter. It's 56, and they told us L is going to be x, or our length is x. And so if I could solve this equation for W, then I'll also have the width in terms of x. So that's what we want. So I subtracted 2x from both sides and then divided by 2, and you get W is equal to 28 minus x. And so that's where I got, oops, that should be 28. And then at that point you need to remember area is length times width. So it's going to be x times 28 minus x. And so that's where they get this answer here of C. So notice in the end we have an area function where the area is a function of x, which is the length. All right, let's move on to number 22. So we're solving this system using Gaussian elimination, and I'll just warn you that this was not a really nice problem. We end up you could probably do it, but you'd have to use a little different approach than we normally use, or you know, the bottom line is you're going to most likely have to use fractions here, which is what I ended up having to do. So I wrote this down on some paper to prepare for you guys. So I put all of the numbers, I wrote it as an augmented matrix. And here's the problem, is there's no nice way to get a 1 here, which is what we're trying to do. Remember, we want to get it in this form here, and then numbers everywhere else. And then once we do that, we can use back substitution. And so this is what we call just Gaussian elimination with back substitution. We're not getting the zeros above the ones here, although you could certainly do that. Okay, so the first thing I did is I divided everything by -4 to get a 1 here, which we write as multiplication by the reciprocal. So dividing by -4 is the same as multiplying by the reciprocal of -4, which is -1/4. So -1/4 times row 1 will become the new row 1. So notice the second and third rows don't change, and I just divided each of these by -4 to get what I have here. Now, once you have the 1 here, you want to use it to get zeros below. So if I multiply the first row by 8, when I add these rows together, I'll get a 0. So we're going to do 8 times row 1 and add that to row 2, and that becomes the new row 2. Similarly, if I multiply the first row by -6, when I add these first terms, I'll get 0. So -6 times row 1 added to row 3, that's going to become the new row 3. All right, so I went ahead and did that work, and this is what you get. So first of all, I have the 1 with the zeros below here, and so I move down the main diagonal, and now I want a 1 here. So I can just divide by 4, or again multiply by the reciprocal, so that's what I did there. And I also thought it'd be nice to get rid of these fractions, and so I multiplied the third row by 2, and so that gives you this row here, or these 2 rows. So now that I have a 1 here, I want to use it to get a 0 below, And so I multiplied the second row by 3, and I'm adding it to row 3, and I'll get my new row 3. So the first two rows don't change. And you should get what I have here. Now the only thing left to do is I need this to be a positive 1, so I just multiplied by negative 1. So row 3 times negative 1, and so finally, oops, let me move this down a little bit. We get this matrix here. And so now we can write this, and actually this turns out to be pretty nice. I can write it as a system, as equations. And notice y is 0 and z is negative 2. And so even though I have to deal with fractions here, at least the numbers aren't too bad. So it's x plus 0 times 3/4, which is 0, plus 1/4 times z, which is negative 2, equals negative 3/2. So we're just plugging in here. And when you solve that, you get x minus 1/2 is equal to negative 3/2. I added a half to both sides, and you end up getting negative 2. Whoops, did I do something wrong there? 1/2. Well, actually, yeah, this is negative 3 plus 1, which is negative 2. Negative 2 over 2 is negative 1. All right, that's what I did. So finally, you would write your answer as the order triple, negative 1, 0, negative 2, using these values that we just got here. All right, let's go back and let's look at 23 here. So for this function, this is an exponential function. The parent function would be y equals 2 to the x. Now, I went ahead and I graphed that. Remember, we would choose x to be negative 1, 0, and 1. And when you plug in, like 0 here, you get 1. If you plug in 1, you're going to get 2. And if you plug in negative 1, you get 1/2. So these are the three key points that we use to graph that function. And then we look at our shifts. This minus 3 is going to cause us to have a vertical shift down 3. Now the plus 4 is with the x in the exponent, which causes a horizontal shift. Those are the ones that work the opposite of what you normally would think. And so we're going to, instead of right 4, it would be left 4. So you're going to take each of these points and move them down 3 and left 4. And actually, you just had to fill this part out here. So start with the graph of 2 to the x, shift it left 4 units, and down 3 units. Use the graphing tool to graph the equation. And let's see, I think that's all I need to show you there. I mean, it just basically, you take these points and go left 4, so 1, 2, 3, 4, and down 3, 1, 2, 3. The other thing is there is an asymptote right here, and so when you move that down 3, it puts you right here. And if you move all your points, you're going to get these points here. All right, let's go ahead and look at number 24. So on number 24, you're given some information. You're supposed to find the average rate of change, which is just another name, excuse me, another name for slope. So we're talking about the number of visits to public libraries It went from 1.3 billion in 1993 to 1.4 billion in 1998. So that gives you 2 points. Now time is going to be your independent variable. That acts like x. And since we're going to start at 1993, we'll call that 0 at time 0. So that's our starting point. 1998 is 5 years later. So it's the number of years since 1993. Now you could actually just use 1993 and 1998. This just keeps the numbers a little nicer, especially once you put them on the graph. And then the 1.3 billion, that goes here, and the 1.4 billion goes here. So we'll use our slope formula, and it's 1.4 minus 1.3 over 5 minus 0. And when you simplify that, you end up getting 0.02. Now keep in mind, this is the change in the number of visitors. So the change in visitors over years, so it's visitors per year is going to be our final answer. So it's 0.02 billion visits per year. All right, and I guess that's how you can fill this in here. Number 25. So function or not, and find the domain and range. Well, the domain is just the x values from these points. The range is the y values from the points. And they're in braces. This is not a function because notice x repeats. In fact, if this were the function f, you would say f of 2 is 3 and f of 2 is 1. And we can never have the same input with two different outputs. So that's definitely not a function. But we know when it's a set of ordered pairs, if x repeats, it's not a function. Let's look at number 26. So first of all, on the left I have 2 logs, and I'd like to make that into 1. I can use the quotient rule. So it'll be the log of this number over this number here, or the log base 3 of x plus 1 over x. And then we still have 4 on the other side. Now this is an exponential equation. Notice base, exponent, answer. In fact, I like to use a little round the world there to give me that. So 3 to the 4th power is equal to this. And so I just wrote the x's on the left, but that's what I wrote. Just changed to exponential form. 3 to the 4th is 81. And then to clear the x, I multiplied both sides by x. So these guys cancel. You're left with x plus 1 is equal to 81. 81x. Now sometimes students get stuck here because they're thinking in terms of quadratic equations. This is not quadratic. We just need to get x on one side, so we need to get rid of this x here by subtracting x on both sides. And then you get 80x is equal to 1. And so you can solve for x and you get 1 over 80. And by the way, when you plug in 1 over 80 here, you are not taking the log of a negative, and so you're okay. Although checking it can be a little bit of a challenge if you want to go further than that. Of course, you could use your calculator to help you. Let's go ahead and look at number 27. Determine whether the function is one-to-one. If it is, find a formula for its inverse. So this is a rational function. This one's not too bad, but it does take a little bit of time to graph it. Basically, you know that you have a vertical asymptote at x equals -6, so that's where I put that. And since the degree of the bottom is larger, your bottom heavy, you have a horizontal asymptote at y equals 0. I didn't actually check this one, but it's either like this here, or it could be like this here. This is my first guess. But in either case, it would be 1 to 1. It would pass the horizontal line test. And so then it's just a matter of doing the steps for finding an inverse. So first of all, you change f of x to y, and then we're going to want to interchange the x's and y's, or switch them basically. And then to clear the fractions, I multiplied both sides by y plus 6. So over here, you'll distribute. You'll get xy plus 6x is equal to, these guys cancel, and you're left with 4. Now, I want to solve for y, and so I get the xy by itself and then divide each side by x. So at this point, you could write your answer like I did here, or notice 4 over x minus 6x over x. This would be the other way to write your answer. All right, we're down to our last problem. Where you have to solve this system using row operations. Let's see. Oops, I don't think I have that. But anyway, that was, you're supposed to use Gaussian elimination or Jordan-Gauss elimination to solve this. And so let me just show you how you would want to do that. So I went ahead and I made the augmented matrix. Now I could do like I did on the earlier problem that I did for you where we had no solution. And on that one, we got a 1 here. But I'm looking at this, and I know if I multiply by 2 here and here, these guys are going to add up to 0. Right? 8 and negative 10. When you add, you're going to get 2 zeros. And so, oops, what did I do here? No, so I just multiplied the first row by 2. And then I'm going to add the first and second row, and that'll be my new row. So I never did change this to 1, but the reason why, I was expecting to get a row of zeros, and this makes the math a little bit easier. So in this case, I know I'm going to have infinitely many solutions. The reason why is these are the same lines. That's why everything fell out. And so how do I write my answer? Well, there's 2 ways to do it. Now, usually what I do is I let x be the variable for x, and then I find y in terms of x. In this problem, they did this to us, and they put a y here, which means we need to write x in terms of y. And so that's what I did here. I solved for x. I got rid of the 4y by subtracting 4y on both sides, and then I divided by negative 5. Negative 4 over negative 5, that's going to be 4/5 times y, plus 7 over negative 5, that's minus 7/5. And so this will be 4/5 y minus 7/5. All right, and so that's it for the review. If you have any additional questions or need any clarification, just let me know.